So why do we use Kubeflow in Kubernetes, right? Why did we need to use Kubernetes, or why should we use Kubernetes for a specialized ML platform? Well, because we have the power of pods and we have the power of the portability of container images, and we can create that composable layer of taking what a developer or a data scientist is exploring locally, being able to bring that into a namespace, and then take that namespace and potentially share with other collaborative data scientists, including potentially the data itself. You've created a lot of portability between your environments, as well as orchestration and how something should be ran. You have this operator that is saying, this is how an application should be deployed, and proving that simplicity. You have controllers validating that it's still healthy in that environment. You're no longer carrot feeding these pods. They can come and go as they please and make sure they get the appropriate data and volume, et cetera. And a lot of that simplifies a lot of the cognitive load and complexity that managing traditional infrastructures and machine learning workloads provide, right? So Kubeflow gives you that that translation to Kubernetes, which is translation all the complexity underneath. So continuing up that abstraction layer to really focus on getting data scientists to build pipelines to get code to production. Here's again, when we talk about Kubeflow, it's a lot of different working groups, which is another huge value of Kubeflow. All of these different bits and pieces are different microservices, but Kubeflow allows them all to work together in a really nice way. And empower you to use that notebook to define that pipeline to build things out and run your workloads. You'll see also on the right, we got things such as Istio and Argo, Prometheus. These are really what help work within Kubeflow to work with Kubernetes to deploy what you need. Liz, as well as the central dashboard, et cetera. This, we can go to a more specified Kubeflow session to deep dive into all of these, but there's a lot of different components within Kubeflow beyond just the platform. It's worth noting that notebook servers are stateful applications. When you create a server, pods will request storage, right? They'll request storage using a persistent volume claim that's going to have a persistent volume. Persistent volume claims have some node affinity. They make sure that they're getting that right volume. And pods facilitate resilience, because since that service, when you restart that service or whatnot, it understands how to get to the right volume. It really helps you with that state. So you can do cool things like just decide where you want your notebook to run or how you want to provision that notebook, because since that notebook's just a service, right, it doesn't have a personality yet. Once we present that volume to the notebook and that image, all the dependencies come with it, and we can start to upgrade and deploy that wherever we want. And so that's really how you can start to use the power of Kubernetes and notebooks to get the resources for your jobs that you need. So if you open up the hood on what a notebook server is, it runs in a container, which is in a pod. Request a CPU that supports the notebook server, and then the pipeline steps execute within a pod. So when you declare a pipeline step, what it's doing is it's not taking your Jupyter notebook and running within it. It's actually making a request to the Kubernetes or the Kubeflow server, which is requesting Kubernetes resources. That could be a GPU, right? Within Kubeflow, you can protect your GPU nodes to deploy things. And since each of these jobs is just an individual step, you can choose at an even more granular level, hey, I've only got a really GPU proficient step. Let's only deploy that one step in my entire pipeline. So you can have a bunch of different data scientists running a bunch of different pipelines, and only in their respective pipelines, the steps that need a GPU can be deployed on your GPU nodes. So that's really powerful, in that developers and data scientists can declare what types of resources they need, as well as we can limit, obviously you can limit like, hey, you don't want to maybe have a 32 gig job right off the bat. And if you do need to that, well, let's make sure that we can use the power of Kubernetes to deploy that on a node that has enough resources. So you can start to really constrain how you want to run and make sure that you don't go outside those boundaries. So you can manage the efficiency of your kube costs and scale in a bunch of different ways besides just vertically, right? You can choose how you want your pipelines and your application to scale all the way up to serving. So we talked a lot about pipelines. And for those who haven't gone into KFAS and kicked off a pipeline, this is what it looks like. So you can see right off the bat, you can choose Kubernetes, hey, provision for me 2 volumes. Let's load in the data. Let's start splitting the data, right? You want to have your data that's for training. You want to have your data that's for validating. And then you can go and handle that pipeline. This is kind of an example of a really good continuous training pipeline. And this was declared right within a Jupyter notebook using Kale. So instead of saying, I want a container with this image, I want to build out all these things, you actually can just tag your notebook cells, hit go, and all of this will be done for you. So this was all within the notebook without really needing to understand how Kubernetes does what Kubernetes does, but still having that power. So all together, right? What is this? How does this work? So within your notebook, you're building your functions, right? You're building how you want your data to be controlled, transformed, trained, and used to build out a model. Within that notebook, you can kick off stateful sets, right? So we use Rock, it lets you use local storage, kick off that stateful set, get a volume claim for marshaling between pipeline steps. And then with that, it allows you to choose what types of resources you want and confirm that they're available on your nodes and or scale up nodes should you need additional resources.